Hello everyone, and welcome back to another video about IB Math. In today's lesson, we will be studying implicit differentiation, which is an important topic in calculus in the IB Math AA high level. Now, before we continue here, I would recommend that if you don't have enough knowledge of the chain rule in differentiation, you can watch first the video that appears top right of the screen about the chain rule, because we need the chain rule and we need to understand it well to understand implicit differentiation very well. So first, what's implicit differentiation and when do we use it? And what's the difference between implicit differentiation and the normal one? We will study it in today's lesson. Let's start first with this function or expression here. We have 5x plus 1 power of 3. And now we need to differentiate this as we learned before in the chain rule. So first, to differentiate, we denote the derivative of y as dy over dx, which will be, here, to differentiate this bracket power of 3, we drop the 3 down first, then it will be 3, 5x plus 1, and all of that will be the power of 2 here, which is 3 minus 1, 2. So we decrease the power by 1. But after that, according to the chain rule, we shouldn't forget that we have to differentiate the inside of the bracket here, which is 5. So if you differentiate the inside of the bracket here, you will get only 5. And now you can simplify here. 3 multiplied by 5, 15. So here we will have 15 multiplied by 5x plus 1 and all of that squared. So this is the derivative here. But here we didn't need implicit differentiation. You notice that y is written alone. It's the subject. It's isolated. It doesn't have any power, or it's not multiplied by x or anything like that. So what if y here is, for example, squared or cubed or multiplied by x cubed, for example? In those cases, we need something called the implicit differentiation. So, for example, you might have an expression like this, y cubed instead of y. How do we differentiate y cubed? We know that when we differentiate x cubed, the derivative here will be 3x squared. So what about y cubed? Will it be only 3y squared? So here, to differentiate it, we will apply also the chain rule. First, also we put the 3 down, so it will be 3 multiplied by y squared, as we do here. But after that, according to the chain rule, we differentiate the inside, what's under the power, which is only this y here. As we differentiated here the bracket and we got 5, here also we will differentiate only the y inside, and as we know, the derivative of y will not be 1, it will be dy over dx. So this is the derivative of y cubed, which is 3 times y squared multiplied by dy over dx. In the same way, for example, if we have, let's say, y squared, then the derivative of y squared will be 2, then y power of 1, and then we differentiate the inside, or y, which is dy over dx. So here, this is the derivative of y squared. So what if you have only y? As we know, the derivative of y will be just dy over dx. And the same rules can be applied on other functions. So for example, as you studied in the chain rule, for example, if you need to differentiate 3x squared like this, e power of 3x squared, first we differentiate the power, and that will be 6x multiplied by the same e, so 3x squared. We differentiate this power here, which is 6x. So this is the derivative. What if it's, for example, a to the power of 3y squared? In that case, also we differentiate this power first, which will be 6y, but then you multiply by the derivative of the y under the power of 2 as we said before here, which will be dy over dx. So here the derivative of 3y squared will be, we put the 2 down, 2 by 3, 6, times y power of 1, times the derivative of the inside under the power of 2, which is dy over dx, and then we multiply by a 3y squared. So here, this is the derivative of this expression. So keep in mind, whenever you differentiate any expression that has y, the derivative must have dy over dx. Here, the derivative of this must have dy over dx. Here, you have dy over dx, and for the y as well, and here you have dy over dx. Let's now have more practical examples. Here we have expressions we need to differentiate with respect to x. So here, as we see, we have a product between x squared and y cubed equals 7. We differentiate here each side separately. And since we have here product between them, we will apply the product rule. You can watch the video about the product rule that appears also top right of the screen. So to apply the product rule here, we differentiate x squared first, which is 2x, times, we keep the second one as it is, y cubed. So we have y cubed. Plus now we do the opposite. We keep the first one, x squared, but we multiply by the derivative of the second product, which is y cubed. And when we differentiate y cubed, as we know, we put the 3 down, then y power of 2, then differentiate what's under the power of 3, which is dy over dx. We shouldn't forget it. So we finished differentiating the left side. The right side is a constant number, which is only 0 when you differentiate it. So this is here the derivative. Now we will simplify and make dy over dx the subject. So here we can simplify. It will be 2xy cubed plus, here we have 3x squared y squared times dy over dx equals 0. Then we can move this to the other side or subtract it. So we will have dy over dx. So here we will have 3 x squared y squared multiplied by dy over dx equals negative 2x y cubed, and then we divide by what's multiplied by dy over dx. So here dy over dx will be negative 2x y cubed, and all of that divided by 3x squared y squared here. And we can simplify, so cancel x up and down, so the derivative will be negative 2. Here we can simplify or cancel 1x from both, and cancel here y squared also from both. So we will have y only divided by 3 only, and 3x I mean, because here when we cancel x from both, we will have only x down, and when we cancel y squared from both, then we will have only y above. Another example given here. So here we have an expression like this. So to differentiate this, first we differentiate x cubed, which will become 3x squared. I will remind you of how we differentiate sign using the chain rule. For example, when we differentiate sine x squared like this, first the derivative of sine will be cosine x squared as given in the formula booklet, but after that we differentiate what's inside, which is 2x. So multiply by 2x. This is the derivative according to the chain rule. Here also, to differentiate this, first we differentiate the inside, which is The derivative of y squared, as we said today, it's 2 times y times the derivative of the inside, which is the y. So dy over dx. Then multiplied by. After that, the sign will become cosine as we see here. So cosine y squared equals the derivative of 1 is 0. So this is the derivative. Now, if we move 3x squared to the right, then 2y dy, or we can write it like this, 2y times cosine y squared, then dy over dx equals negative 3x squared. Finally now, to make this one alone, then dy over dx will be negative 3x squared divided by what's multiplied by dy over dx, which is all of this. So here we have 2y cosine y squared. This is now the derivative of this function using implicit differentiation.